Good morning, everybody. This is Ms. Billerbeck, and we're going to talk about set notation today. So set notation. Set notation has several different sections of it. First, we'll talk about, well, what is a set? What are equal sets, subsets, universal sets, empty sets, and a complement of a set. So let's start with sets. What are sets? So let's look at a set of merganser ducklings, one of my favorite to see when I paddle on the river. There they are. They all stick together, and boy, those merganser moms have a ton of little ducklings. So, and they're very good swimmers. And a set of dry erase markers. Well, we know all about those. Didn't you notice how happy I was when I got all my colored dry erase markers from Amazon Prime? Awesome. Then we could have colorful lessons. A chemistry set. Now that's something I always wanted when I was a kid, but I didn't get one. A set of math books. Well, you guys know that I'm always have those. So, and then we have a set of kittens. Oh, so cute. And a set of puppies would be super cute too. So in mathematics, we use the term set to mean a collection of well-defined, distinct objects. Set notations used to organize, classify, describe, and communicate a relationship between things. So let's talk about set notation. So we'll use capital letters for the names of sets. So if I say capital letter A equals Friday Cahoots games, that would be a set. And notice these little brackets here. Those are set symbols. These are my elements in the set. So set B would be video games. I know some of you out there would be so happy to have that set. And then best novels. We are a classical institution, so we read. And set D is 1, 2, 3, 4, 5. Can't have math without those numbers. So let's look at set builder notation. So it's a little complicated. So this was a nice little image that I found. So the set of, so if we notice the set of are these brackets, all x, so all possible values of x. And then this little thing, remember how it means two in a proportion or a ratio? Well, when it's in set notation, it means such that. So all x such that x is less than 2 is the set. Okay, so this would be set A is the set of all x that such that it's less than 3 and less than 7, or greater than 3, sorry, and less than 7. So this x means it's greater than 3, by the way. So let me say that again. X is greater than -3 and less than 7. So that would be set A. Okay, so if we look at this set, it means the set of all x such that if x is a member of all real numbers, that's another way to write all real numbers, x, except x can't equal 17. Okay, so that's the only restriction. So that is the set of x values. All real numbers except 17. Poor 17. So what a math, the set builder notation, look at this. It's the same kind of thing, but look at this. So this means the set of all x such that x is greater than 0. Okay, so you might see this bar instead of these colons. I'm used to this actually, so that's why I looked for it. So we can write set B equals is a set of all x such that x is less than or equal to negative 21. So that's how we would read that. So basically, set builder notation is we have a variable like x such that it meets certain conditions. So we can use this colon, or we can use this bar right here. Okay, both of these mean such that. So then we have elements. Well, what are elements besides mercury and gold and silver? There's elements in math that aren't minerals. So objects in a set are called elements. So the set of A, such that it's all best novels, such as Gulliver's Travel would be a member of set A, since Gulliver's Travel is an element of A. Okay, so this means Gulliver's Travel is an element of A. Okay, with set B, it's the set of all best songs. So the set A is not a member of set B. So A is not an element of B. Sorry, A is not an element of B. Good thing I wrote out what it really means. I even get confused. So that's why you might want to go over this a little bit more on your own. So the number of elements in a set is denoted by the number of elements in set A. So meaning the number of elements n in set A. Given D equals 1, 3, 6, 8, 15, 16 as a set, the number of elements in D are 1, 2, 3, 4, 5, 6. There's 6 things in the set. So there's 6 different elements in set D. Given A equals the letter of scholars, the elements of A are S, C, H, O, L, A, R, S. So what is the number of elements in A? Well, we count 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 elements in the set of A. Okay, here's an example. Given the set B equals the colors of the American flag, the number of elements are red, white, and blue. So the number we would write in our math shorthand, number in set of elements in set B equals 3. Red is an element of B. Here's another example. Given T equals 3, 4, 5, 6, 1/3 is not an element of T. It's not in there. Nope, not there. So meaning 1/3 is not an element of T. So see how easy it is to write our math shorthand versus writing all this out. Okay, we're very efficient in math. That's why math is a different language. Yes, think of it as learning Latin. Okay, T equals the set of X such that 3 or X is greater than or equal to 3 and less than or equal to 6. So that means it could be 3 4, 5, 6, if we were only talking about integers. But if it's all of those numbers, then it's all the possibilities between 3 and 6, including 3 and 6. Or we could have written T is the set of X such that X is greater than or equal to 3 and less than or equal to 6. So either of these say the same thing, okay? This is just a different way of saying such that. Two set A and B are equal. That is, A equals B if they have exactly the same elements. So let's look at that. Given T equals colors in a rainbow, and W equals colors in a rainbow. So T equals W. There you have it. That's what an equal set is. Subsets. If every element of a set A is also an element of a set B, then A is said to be a subset of B. You write A, set A is a subset of B. If A is not a subset of B, then A is not. This little line right there means not. So don't forget your not when it's a not. Okay, so if A is not a subset of B, then A is not a subset of B, is written like that. Okay, if A is a subset of B and A does not equal B, then A is a proper subset of B. So we would write A is a proper subset of B. That means A is a lot of the elements of B, but not all the elements of B. When A is not a proper subset of B, then A is not a subset of B. Don't forget the slash. Example. Let P equal 1, 3, and Q equal the set of 1, 2, 3, 4. R is 4, 3, 2, 1, and S is 1, 3, 5. So how do P and Q relate? So we're looking at P is 1 and 3, Q is 1, 2, 3, 4. Well, P has 2 elements of Q. So P is a proper subset of Q. Well, how do Q and R relate? Well, this is 1, 2, 3, 4. This is 4, 3, 2, 1. Hey, those are the same numbers. Q is equal to R. Whoops. And P and S. So P, we have 1, 3. S has 1, 3. So there are 2 elements of P in here. So P is a proper subset of S. So we have that again. What about Q and S? Look at that. This one has a 5 and that one has a 4 and a 2. So, we're going to have to say Q is not a subset of S. So let's talk about a universal set. The overall set of which every set is a part is a universal set. The Greek symbol used for the universal set is psi. Okay, I think I'm pronouncing that one right. It's hard to find a translator for these Greek letters, so correct me if I'm wrong. Okay, so what's the universal set for psi? Well, let's see. Q equals as a set of drill, screwdriver, hammer, saw. What would be the universal set? If you guess tools, that would be correct. That would be right. Okay. How about the set R is the set of all the numbers that go from beyond -3 to -3, -2, -1, 0, 1, 2, 3, and then all those numbers above. So what set of universal set does that belong? Integers. There you go. So let's look at the empty set. If a set does not have any elements at all, it's called an empty set, and it's denoted by the Greek letter phi, or this double bracket with nothing in it. So that means empty set. Okay, the empty set is also called a null set. So you might see that. The set of 212 Fahrenheit days, boiling days in Sacramento, is an empty set because we would die if it was that temperature, even though we say it's boiling in the summer in Sacramento. It really isn't boiling. 113 or 114, maybe even 150. It's livable. In Arizona, it's like 120. They're still alive. So we aren't truly boiling. So it's an empty set. So we would say the set of 212 Fahrenheit days in Sacramento is an empty set. So the empty set is a subset of every set. So phi is a subset of A, is a subset of the universal set. Okay, C. Okay, so here's an example. If A is the set of 1, 2, 3, 4, list all the subsets of A. Well, that's going to take a while. Okay, well, we can't forget phi. Then there's 1, the set of 1, the set of 2, the set of 3, the set of 4. But we're not done yet. There's a set of 1 and 2, 1 and 3, 1 and 4, 2 and 3, 2 and 4, and 3 and 4. But we're not done yet. There's a set of 1, 2, 3, and 1, 2, 4, and 1, 3, 4, and 2, 3, 4. But we're not done yet. And then there's a set of 1, 2, 3, 4. Now we're done. Those are all the subsets. A complement of a set. A set is a set of is a subset of a universal set A. So A is a subset of a universal set Xi. Sorry. Elements of Xi are not in set A. So there are some elements in Xi that are not in set A. So A is a proper subset of the universal set. So these elements in set A are called the complement of set A. So if you combine the complement with set A, you have the universal set. So we would write the complement of A with a little apostrophe. So that means the complement of A equals the set of all X such that X is an element of the universal set Xi, and X is not an element of A. So that's how you would write it. Pretty crazy that that means that. Let me repeat that. The complement of A equals the set of all X such that X is an element of the universal set Xi, and X is not an element of A. That is a complement. And that is quite something for that to mean what I just said. Huh? Isn't that true? I told you this is like Latin. It's a different language. So let's look at another example. So X is xi equals, so the universal set is A, B, C, X, Y, Z. And P equals B, Y, Z. Q equals X, Z, Y, C, A, B. Okay, so what are the elements of P prime? So we look at P and we look at the universal set. Well, this one doesn't have A, and it doesn't have X, and it doesn't have C. So it doesn't have A, C, and X. It just has the B, the Y, the Z. So the complement of P would be A, C, X. So what are the elements of the complement of Q? So if we look at this, we're like, oh, come on, you're trying to fool me here. This is the same elements as this. So that means that it's a null set, phi or phi. Okay, so phi, phi, pho, phum. There you go. But this means null set. Okay, excuse me on my pronunciation of Greek letters. So, so that's an empty set because this is the same thing as the universal set. So there aren't any elements that aren't in Q that are in the universal set. So the complement of Q has nothing, nada, it's empty. And that is the end of set notation. Okay, well, I hope you have an amazing day. And I'm going to try to figure out how, there we go. I finally found the screen. I hope you have an amazing day and be safe and well and enjoy our rainy day. Bye.